Hello. Here's our second video for the distance formula. The first one was just a review of the Pythagorean theorem. So now that you just saw that quick review of the Pythagorean theorem, here's a warm-up exercise for you to do, is find the lengths of the hypotenuses of these two triangles using the Pythagorean theorem. And as usual, try it first on your own. It's okay if you get it wrong. Don't worry about that. Just make sure that you try it on your own when I say to pause it, and then also write down the correct answer on the side. And leave both of those in your notes so you can turn it in if you have to. And here's the place to pause it. Here are the answers I got. We're using the Pythagorean theorem here, which says that the hypotenuse squared, which is like the C here, the longest side of a right triangle, the side opposite the right angle, if you square that, you get the same thing as the other two sides squared added up. So in either of these cases, the side opposite the right angle is the D, so we have our D squared equals the 30 squared plus 40 squared, and when you combine those, you get 2500, and when you take the square root of that here to cancel out with the D squared to get just D by itself, you end up getting 50 meters. And same thing with this other one, the hypotenuse squared equals the sum of the squares of the two other sides, and you end up getting D is the square root of 2 feet. So let's use that concept now to the same sort of approach to figure out the distance between some points. Because as we're going to see, the distance between points we can think of as the hypotenuse of a right triangle, which is what we're going to see right now. So I'm going to take the point 1, negative 2 is right here, and the point 4, 3 is right here. And what we're talking about is the distance between these points. That's what I'm going to call D here. And what we're going to do is say, oh, hey, look at this grid. It looks like there's basically already a right triangle drawn here where there's that horizontal side and this vertical side here that are along the grid lines. And so, of course, they're going to have a right angle there. So how can we find the lengths of these sides? And once we know those, we can figure out the distance. Well, I mean, you could just count it in this case. This doesn't usually work for most problems, but because you don't always have a grid here and you don't always have these nice whole numbers. But in this case, you can just count 3. But you could also think of that as like the delta x when you're doing a slope problem. How do you find the change in x? You take the bigger x coordinate minus the smaller coordinate, or maybe just the second one minus the first one. So in that case, we're going to take this 4 and the 1 there and say 4 minus 1 is 3, is how you can get that. And then how do we find out how long this side is? Well, we're going from negative 2 up to 3. This is kind of like a delta y here, that vertical side. And the way you can calculate a delta y is doing the same thing. Take the second y coordinate minus the first coordinate, the 3 minus the negative 2, and that way when you compute that, you get 5. 3 minus negative 2 is positive 5. So that way we can say that the distance here, if you square it, what we're trying to find there, that distance squared is equal to the sum of the other sides squared. And you can think of it as like a delta x squared plus a delta y squared. And just like with the previous problems, if you actually want to find a formula for d, you want to find the distance itself, you could just write that as that distance is equal to the square root of all of this stuff. Because that's all we're doing is just taking the square root of both sides of an equation. And so you get that. And notice, of course, this doesn't actually cancel out. It's not the same thing as just delta x plus delta y, because square roots, like a lot of other things, don't really have a distributive rule here. That makes sense. So it gives you that. But then we also have the numbers here. So I could also write it in this other format, replacing the delta x with 4 minus 1, and call it d equals the square root of that delta x squared, but the delta x is 4 minus 1, like I was saying, which is going to come out to 3, of course. We have that plus the delta y squared. The delta y I can also just write as 3 minus negative 2. And anyways, then you can do it. You end up getting the distance is equal to the square root of 3 squared plus 5 squared, and that's going to end up being the square root of 9 plus 25 is 34. And then you could do that with a calculator if you want to get an approximation, which is usually a good idea if you have any kind of real-world problem. So you get 5.83 approximately. But okay, so that's how we can use the Pythagorean theorem to find the length of a side like so. Now, let's also see how you can derive a formula for the distance between 2 points in general. And we're going to do the same idea as before. It's just that, what if we don't actually know the coordinates of what we were doing? We could still say the same things will be true. So I'll do it on this other side over here. We're still going to say the same thing about the distance, because it doesn't really matter what specific points you have. They could be anything. So maybe you have another triangle that looks like this. Is equal to y2 minus y1, which in this case is -1 minus -3, which comes out to be 2 here. So that's what we're going to do, is the same thing we did before, is just say we're going to take the square root of both sides of this. We're going to try to get an answer that is in terms of x2 and x1 and y2 and y1, so that you can just plug in the coordinates into this formula for any point. So then we're going to have, we can then say, well, how do you get that delta x and that delta y, just like we did before here. Whoops. Same thing as before. It's just that now we're going to call this, excuse me, the delta x is, we're going to write it as x2 minus x1, so that now it can be written in terms of the x and the y coordinates, like I was saying. So this is also going to be y2 minus y1 here. Anyways, this is the distance formula, and you can plug in your particular x1 and x2 and y2 and y1 for any pair of points that you have, and we'll do a few examples of that in the next video. And I just wanted to make sure there's a box around this, because what I just derived, that is what this section is all about. It's kind of all about the distance formula, because we're skipping the stuff about the midpoint. So the distance between 2 points, x1, y1, and x2, y2, is this: the square root of the sum of the squares of the differences in the coordinates. like it's written out. So we'll do an example in the next video of computing that.